Thank you very much, Shahid, and a very warm welcome to everyone out there listening in. This, as Shahid said, is a joint session between PTC and Configit. So in our session, we are going to argue for getting configuration into the digital twin and the digital threads of our products. And we will argue using two viewpoints. So the first one is looking at the product lifecycle as we know it, the different steps a product goes through. But the second viewpoint is from the customer lifecycle. How does the customer perceive the products as it's being offered to the customer, being purchased, being commissioned, used, and maintained as it goes along? Now, we know CLM can be challenging. And one of the challenges is that there's a lot of IT systems in the enterprise that need to collaborate in order to create a shared, combined set of configuration data. So Florian will start by looking at all these IT systems, how things are being connected, and give an overview, look at the different viewpoints that are talked about, and look at the digital twin. And after that, I will take over and I will present a concrete customer case, then show and illustrate how that can be done in the real world. So, over to you, Florian.
Thank you for having me here at the CLM Summit. So I'm especially proud as PTC that we can present here today also our viewpoint. We have a lot of configuration management in our solutions, and I think it's important to understand how that plays with the rest of the enterprise. And that's what I want to cover, maybe starting out with a few key points that I want to make on what we observe with our customers. So first of all, like we already emphasized during this session a lot, is our customers produce more and more variants for reasons that they want to be more specific to their customer needs, being more to the point, and for that better in competition, but also for other reasons like regulatory is what we have seen just in the presentation before. But having all those configurations basically comes down to, first of all, engineer all of those. This is where PTC plays a big role. But also then use all of those configurations across the lifecycle. In fact, the ability to handle all of those configurations and the variations across the lifecycle becomes a key capability for all those companies to realize all the economic benefits that they hope for when they create those variants. So this means everything needs to be implemented along the entire value chain, and with that, of course, there is a big need to have everything implemented across multiple IT systems. And how should that work? Well, this is what I'm going to cover. I think a central notion of this concept is the digital thread. So that basically means having all the internal functions working together, engineering, manufacturing, and service, so that they have sort of a continuous data flow to where they sit upon. But it also, of course, means to have all the external aspects covered. First of all, supply chain, so all the incoming goods that help you to produce the products, and also the customer operations, what we will see on the next slide. So my claim is at this point that basically configuration management is a core capability that you need to have as a basis for digital transformation. So why should you? So first thing is, digital transformation means integrate all your processes, have them flow more smoothly through your organization to gain those internal operational and efficiency gains. So that comes basically from an ideal world where your customer or your salespeople configure a product and there is no touch really in the organization on defining how that product should be built, how that product should be delivered, and how it should be serviced afterwards. Everything should be clear after the order, ideally, which is not the case in many customers we know. And the second thing, and that is the expansion to the digital offerings. So companies want to not only sell their products anymore, they want to have them accompanied with a lot of digital services they offer to their customers. That might be things like simple things, only internal customer portals, but still you need to understand what's the configuration of your customer. They want to do remote monitoring to really understand the data that's coming off the machines. You need to understand what is the configuration the customer is operating. If you're offering as a service capability, so the customer doesn't really pay for the machine, but maybe for the outcome of the machine. Also there, it's an essential thing to understand what the customer really has in field. And also, if you stay with quite traditional business models, still improved on-site service experience is crucial. It's crucial for your competition. It's crucial for the customer success. And basically, it should help you to have better first-time fix rates and lower service costs. And then, of course, when you look into more complex, more capital-intensive products, you would see other things like there might be product upgrades that are done after a certain while with the product. The product might be better integrated with its environment. You would need to have more or less complex processes to find the right spare parts if your equipment is becoming more complex. And finally, with all the sustainability regulations, you would also need to understand what is coming back to your factory if you embrace to a circular business model, so where you basically reuse parts that are being used from the products in life. So of course that is a big span. Digital twin is a central element to that. Basically, we want to look at it, as you described, Anders, from two perspectives. The one is the product lifecycle perspective, which we take a lot, that goes from product definition, product development, through all the preparation of the sales work, production preparation, service preparation, and then maybe the reuse of the components that might come back. So that is the broad view of a product lifecycle. And within that, we see a customer lifecycle perspective that basically starts with the interest of the customer, which would lead to an initial offer, hopefully to an order, and then the installation, commissioning or installation of the product, the usage and maintenance phase, which could be quite long, and then reuse after that. So with all that, configuration data plays a major role. I will jump over that because I already explained that, and I want to go deeper into what is it that we are going to cover. So first of all, I want to highlight a little bit what do we do for building configuration rules. Then jump into what do we need for order configuration or offer configuration, and then for sales configuration. So if we start with configuration rules, that typically starts with product management. So there might be the first variations might occur in the systems engineering phase, where you think of product concepts and maybe basic variants you want to offer to the different markets and customer segments you have. That is something which defines the basic structures within your PLM system. But also when you go deeper and when you task your engineers then with working on the product, they will come up with an engineering bill of material, as we call it. So that's the basic structure. That's all the parts, the modules, and so on that you're going to use. And there, typically engineers build a 150% view, so all the parts that could go into a product. And with that, they also define at that point the rules where which part excludes which other part, and what are the configurations that are being valid to be built for the product. Then they take a second step and then try to understand what are the manufacturing processes looking like. And also there might be variation, not necessarily creating different products, but maybe you have different production variants because the product is produced in different plants with different suppliers, maybe with different processes and equipment, so that you need to have a slightly different setup there. And also that underlies certain configuration rules. So that is all what goes into PLM. Also, the service rules, service spare parts that you identify play often an important role already in the engineering phase to have those defined. Then those technical rules, once the engineers are done with their work, those are released to ERP. You need in the ERP, you need all the materials available so that you can plan for purchasing those and manufacturing those goods. And with that, you also transfer the technical rules. But at the same time, also other aspects come to that, because your sales organization might take a look at that and say, okay, we want to have a certain price model attached to that. Maybe we want to have country-specific variants. Maybe there should be option packages, the famous sport package on your car maybe, something like that, that are non-technical rules, but which are very important for the success of the company. And then also production engineering might have further variations they add onto that. So there might be conditions that if you order the product in a certain country, it will be built in this factory. or in another factory. So these are all things that are added on top of the technical specification later during the product life cycle, and that might change even at a different sequence. So if you change your technical rules, that's a change to the product. If you change production rules or sales rules, that requires a whole different process. Next thing is I want to focus on the customer perspective. So the first thing, customer gets interested, he wants to have an offer, he contacts your sales guy. So the sales guy, he would basically do an offer or an order configuration for the customer, or maybe the customer does it in a self-service mode that he can do it himself. No matter, basically that configuration is necessary, one, to understand what the product is really delivering towards the customer requirements. So is it good for the customer or not? And second, what is the price for that? There might be, if you have, let's say, complex products, there might be a detour through engineering because maybe you want to adjust the product to the needs of the customer. That will be especially the case with industrial customers, machine builders, heavy equipment, and so on. Second thing is, after the offer, hopefully the customer decides for you, there would be an order, there would be an order intake, and there might be additional configuration steps to really configure the product based on the availability of capacity in the plants to where it needs to be produced. That typically takes place in ERP, might also be in your MES system. And then there's one speciality after order intake. There might also be something, and I think you're talking about a customer example where this plays an important role for big machines. There might even be something like a logistic configuration to find out in which sequence should the parts be delivered to the customer, in which maybe even boxes or containers things should fit in. So that is an important part. And then after the product is produced, either based on the ERP data or based on the MES data, you would have something which we call the as-delivered configuration. That's really the product that the customer gets. And that's the starting point for the service process because, of course, when the customer calls you back the first time, says there's an issue, you want to understand what did we actually deliver, what are the exact parts that we had in there, which lot numbers maybe, and then you apply the service rules on top of it, so you find the spare parts you need and the as maintained. Can basically run the as maintained structure after the parts have been added to the product so that you always are up to date with the product. So all of that is a complicated process, I think. And all of that, of course, requires a good level of control. And that's maybe where I want to hand back to you. I think configuration lifecycle management is really at the heart of managing all these interdependencies. And maybe you can talk about the customer. You are
Thank you.
Prepared.
Okay, very insightful. Thank you, Florian. Let's get this one to go forward. So, I will talk about Vestas. Vestas is a leading manufacturer of sustainable energy, and they happen to be a joint customer between PTC and Configit. So I will use Vestas today to showcase how to achieve some of the things that Florian has already introduced. So before we go into details, and there will be details here, let's start with an overview. Vestas, they use PTC Windchill in order to do all the engineering. So this is where the engineers goes in, do the design, and do the implementation of all their products. They also have a CLM system. This is built using Configit. I will talk about two of the major components in that CLM system today. The first one is the configuration workbench. So this is the place where all the configuration logic and knowledge goes into. And the other one is the sales configurator. This is one of the access points to all that data that lives in the workbench. One thing to notice here is that the Windchill system and the CLM system is fully integrated. And I'll give a few examples later what that means and all the benefits that brings to us. The whole setup is a little bigger. We talked about multiple IT systems in the enterprise. The CLM system and the engineering system is also connected to SAP, and I'll give some examples of what kind of data goes back and forth between those systems. Now, the data that lives in the CLM system can be accessed for many purposes and from many places. Today, we will focus at the point of sale, and that for Vestas is in Salesforce. So with that overview, let's go a little bit into details and see where it takes us. First off, let's start with the PTC Windchill system and look at what is actually authored in Windchill. So when we talk about configuration data, the fundamentals of that is always getting the features in place. So in my slide here, I will color those green and represent those with boxes. Features really, it's a language that is used to express the requirements. When you do design and engineering, it's all driven by requirements to the product. So the features are the language you can use to express those requirements in. Basically, those features, they form the variants of the product. When I say variants, it's important to note that I'm talking about abstractions here. I'm not talking about parts. We'll get to that later. So variants about, for instance, what different kind of power output does different wind turbines gives us. Where is it located? Is it onshore? Is it offshore? The height of it, etc. Another important aspect of what is being maintained in the engineering system in Windchill, that's the rules. So you can say the rules are really the implementation of the requirements and the design from, again, an abstract perspective. So they form a set of truth that says what is possible with the products, what can they do, what can they deliver. These rules here, what they really do is they combine one, two, or more features and say how they interact with each other. Finally, there is the bill of material that's already been mentioned. So the bill of material is really the architecture of the product. And we're dealing with configurable products at Vestas, and hence we're also dealing with configurable bill of materials. Some people call them at 150% BOMs. I think that's what you had in your slides. It's also called an overloaded structure in PTC Windchill. I will just refer to it as a configurable BOM. What makes this configurable is that we annotate this big bill of material, the configurable bill of material, with selection conditions. That's really the implementation of the product. What they are is that they are annotations, pieces of logic we attach to the different parts to say when each part should be included based on what features are selected. The good thing here is that all of that is possible out of the box using PTC Windchill. It's called the variance and option module. And with that, you can express all this logic. What Vestas has done is that they have created a, They've created a link to their workbench in the CLM system. So let's move forward and start talking about sales, for instance. Vestas used the workbench to add commercial and regional market information. So again, having all the data from the Windchill system in the workbench, we can now add on top of it. The first layer we add would be the features that represent the marketing intent. So in essence, while the technical features are the requirements language, then the blue boxes here representing the marketing features, that will be the language of the customer. Basically, that means what type of bundles we would have the product in, certain products go with certain other products, the value you get from your products. For instance, some products might be more sustainable than other products, and the usage of the products. Also here, we add rules. These rules, they represent marketing intent. So that's how the marketing division and the sales division wants to position the products on the market. The interesting thing about these marketing rules is that they combine not just the marketing features, but both the marketing and the technical features. So that way, the marketing rules become a true layer on top of the technical parts. Typically and traditionally, we see that marketing, they want to open up the space. They say, this is what we want to place on the market. While engineering, you can say they close down the space of what you can have, because they say if this doesn't work, then you're not allowed to have it. By combining these two set of rules, we have the best of both worlds. And we know now that what we can offer by this combined set of rules is both what we want to place on the market and what is technically feasible. There's more data added in the workbench that talks about marketing intent. So one of them, for instance, is default. Default logic is a place where you can place information, for instance, about campaigns, things you want to put on the market early, things you can get access to, and suggestions. So for instance, if you have certain features on your product, you might want to have other features that goes well together that in order to get the best experience of that product. Now we have a unified piece of logic, and this one can be consumed by using the automated process that Configit ACE utilizes by putting this piece of logic into what we call a VT package. VT package basically is an actionable piece of data that you can use in order to consume all the data in there. So let's see how that is done. Today I'll talk about the point of sales. There are many other ways to get access to this data, and there are many other usage scenarios. But Vestas use this combined piece of logic in Salesforce in order to offer their products to their customers. So typically what would happen is a customer could come in and open a configurator to get a wind turbine. The defaults would start to kick in and fill out or pre-fill the configuration with current campaigns or good suggestions to getting started based on who the customer is. Then the customer will go through a process of interacting with the configurator. It's a guided interaction that only allows the customer to select valid choices that both want to be put on the market and are technically feasible. And finally, even though the customer might not choose everything that you can configure on a wind turbine, all the rules kicks in and make sure we have a complete picture. And that means that the output of this is a valid configuration that represents the customer's requirements for the product the customer wants, and it's completed not just on the features that the customer is interacting with, the usage, etc., but also on the technical features, since it's all based on this combined set of data. What can happen now is we have the configurable bill of material. So by using this feature string, we can filter the configurable bill of material in order to get to a specific architecture for the customer's product, the one the customer just said, this is what I want. And this actually brings us over to some of the things you mentioned, Florian, about automating the process. And the goal is to achieve an automated order process, basically getting to configure to order. So let's take a look. Now we have the picture, but let's take a look at how Vestas work with data. ACE provides some unique capabilities, both for testing, interacting, and of course configuring. Anytime there's a change to some of the data, Vestas considers that a new version. So that doesn't matter if it's a small change in the PTC windshield system, or if it's a change to the rules, addition of a feature or removal of a feature. What happens is that every little change is considered a new version that should be compared against the previous version. So at this point, it's important to stop and think a little bit, because we know if you're in the configuration business that even a minute change can actually affect millions of valid combinations. But what Vestas is doing here is they're saying, let's project all those changes down to the dominant features. The dominant features for Vestas, if you're talking about wind turbines, are things like the location of the wind turbine. Is it onshore or offshore? How much power does it produce? The height of the wind turbine, the length of the blades, frequency of the power coming out of it. These dominant features are actually what describes what they call a base product. So there's a lot of things you can configure on a wind turbine, but just looking at these dominant features, you know what base product you have. The output of this comparison here is a list of added base products and removed base products. So any little change we put in there could potentially remove some base products. If that happens, it could be intentional. But if it's not intentional, we should go in and analyze what's going on, because we're basically taking opportunities away from what we sell. You might also add some new base products, and that might be great. If these are the right base products that we want to add, what would happen is we would repeat this process of generating the unique architectures, the unique bill of materials for each of these base products in order to go and investigate and simulate and test each of these base products. So by that, we know for every little change what base products are brought to market and what are potentially removed from the market. At this point, something interesting happens, because I remember I said something about the SAP system. What happens is that Vestas has their costing and their vendor data in SAP. So by giving this architecture that comes out for each of the base products over to the SAP system can accurately calculate a price of that base product. And that means we now have an opportunity for Vestas to upfront create a catalog of all the base products with the accurate pricing sitting next to each base product. When you configure and you add something on top of the base product, that's an addition to the base price. But that makes it very robust and very straightforward to do an accurate calculation of pricing for each of these configurations. Now, Vestas, they offer a lot of great things. They do turbines, but once in a while, people come along and they say, I am not configuring a turbine. My requirement for you is to get, let's say, a 500 megawatt power plant. If such a requirement comes in, we're not talking about a single wind turbine. We are talking about multiple wind turbines that needs to collaborate together. And when we have a power plant like that, we're not just talking about turbines, we're also talking about other products. So for instance, a power plant will also have some switchgear to turn the power on and off. And of course, you need some kind of controller to control all the different objects and all the different wind turbines that goes into the system. There can also be requirements, not just how much power do we want. It could be that the customer says, by the way, my power plant is to be located near an airport, so we do need air traffic safety. If that's the case, other things will have to be added to this power plant. So for instance, a ground radar in order to detect planes coming in, and there would probably also need to be some aviation warning lights on the outer perimeter of these power plants. This type of configuration is sometimes referred to as systems configuration. And I think it's fair to say that most people consider that as being probably one of the most advanced forms of configurations, because we're dealing with a lot of complexity, not just in the individual products, but in the whole system that is to be delivered for the customer. So where does Vestas model all of that? Let's take a look. I hope it's not a surprise, but of course they go to the workbench. So in the workbench, they yet again expand the data set that they have. The first thing they do is to add even more features. So these features will talk about things that are relevant for the system, the power plants. Could be things like the safety requirements I just add, or it could be the power delivered by the entire system. Also for the system, we have rules. So these rules, they will talk about something is probably obvious, like the power of the power plant is most likely equal to the sum of the power delivered by the individual wind turbines. But there would also be a lot of rules that talks about the interference and the connections between the different instances of our wind turbines in the power plant. If you put in a controller, you can imagine there could be many different kinds of control system. If you put in a controller on a power plant, we probably want to make sure that all the wind turbines in that power plant talk the same language as that one controller that's put in. So these rules, they're quite elaborate. And again, just like when we put the marketing rules in on top of the technical rules, then these system rules, they sit on top of the other rules. So systems rules, they might talk both about system features, about marketing features, and about technical features all in one go. We also need a structure, a definition of the systems we can configure. So that is also being put into the workspace in order to define these systems or these power plants. And with that combined, we're now ready to do configuration of entire power plants. So what does that look like? Well, it's the same as what we saw before. Now we just have a larger set of data. So once again, we use Configit to combine all the data in the workbench into an actionable piece of data. That's the VG package. And now we can start configuring our systems. The way it works is that we start by a system and say, I want a power plant. And we put in the features for that system. Again, it could be like the power output. It could be the safety requirements. There could be some technical requirements like this power plant is for a certain market, so I need to produce a certain frequency at output. And there could be some commercial aspects on it. Once we have configured the system, what happens automatically is that the system will figure out which instances we need to add in order to satisfy these requirements. So for instance, we want a 500 megawatt power plant, and then we need a number of instances that comes in there of wind turbines. These turbines, again, they need to be configured. So you can go in, they might not all be the same, and configure them individually. They're not just a number of identical wind turbines being put in. If they're put over in the landscape, some of them might be in higher elevation than others, and they might look different than the ones in the valleys. But the important thing here is that when we go in and configure these individual wind turbines, it's done in context of the system. So that means that every wind turbine is of course configured correctly according to the rules we know for the wind turbines, but it's also configured correctly according to the system we're working on. And it's even so that as I'm configuring different wind turbines or control systems, new instances might be added or removed. So at this point, we've come to the point where we can see that we can do the engineering in one system, PTC Windchill. We can design, we can engineer, we can bring it all over automatically. Vestas is capable of adding that into their own CLM system, then adding rules on top of that in multiple layers. Both the marketing rules, the defaults that is relevant when we sell our configurators in, for instance, Salesforce, the systems rules that is relevant for combining entire systems, structure of systems, and we can drive entire configurators for power plants. And we know at this point, since we also brought SAP into the picture, that the prices for each of these instances are correct. So this is a pretty big and full picture. Now, the story continues for Vestas. There's a lot of gray boxes left over here. So we can keep talking about how it's used and reused and decommissioned, but that would have to be a talk from another day. But at this point, we've seen that it's possible to do pretty much everything you started presenting in your initial talk. We gain the value by combining all the different systems, and we have a lot of different IT systems that collaborate in order to create this shared single source of configuration truth to do something even as advanced as systems configurations. And with that, I'll hand it over to you again to do the conclusions.
Thank you.
And the summary of it.
Thank you very much. So I think there is a few takeaways from that. I think distributing configuration knowledge is something which is, I think, not common across the whole industry. Actually, oftentimes we see the customers try to squeeze all rules into one system, but then you get a lot of inefficiencies, especially in the engineering process, because you don't know the context of the parts and the technical dependencies while you create the rules. And also, if you put commercial rules into a technical system, that won't work either very well. So it's good to have a distributed set of configuration rules and make sure that they build on top of each other and basically use whatever is there as the starting point and enhance that with further, let's say, options and limitations. And of course, we as PTC have to say, I mean, the basis for all of that is to have a proper technical concept for the product, because only then, if you know the things that you are configuring they work, first of all, and they are safe to use. There's no, let's say, risk coming out of that. Once we can ensure that, we can do that, building on top of that all the other activities. So with that, I want to say thank you. And back to Shahid.